Welcome to In the Loop, where we break down the complex world of battery manufacturing into bite-sized, understandable pieces. At Northvolt, we believe that batteries are the building blocks of our electric future. But how do they really work? From raw materials to innovative techniques to recycling, In the Loop is your backstage pass to the captivating journey batteries embark on before they power our world. Tune in, be curious, and we'll make sure to keep you in the loop. Welcome back to In the Loop. I'm your host, Nathalia, and in this episode, I am joined by Nathalia Vieceli. We will be talking about how to recycle a battery and its complexities. We will also be going into Northvolt's own approach to recycling. I've been looking forward to this episode for a while, so enjoy. Welcome to the studio, Nathalia.
Hello, good morning. Thank you so much. Thank you for inviting me.
Yeah, thank you for coming. So do you want to just give us a brief introduction to who you are and what you do here at the company?
Yes, of course. So my name is Nathalia Vieceli, and I'm working in the R&D team of Revolt, the recycling program of Northvolt. So I'm mainly working with the R&D that is connected with one of the main operations in the process, that is Hydromet. And yeah, I'm sitting in our R&D hub in Västerås.
So today you'll be talking to us about recycling. And this is a topic that I thought was the most intriguing and most selling part for me with Northvolt was, how do you recycle a battery? I didn't even think that was possible. And then I saw that Northvolt was doing it. So what you're going to talk to us today is the process and how you recycle a battery from its prismatic form or whatever form it could be. It could be in all different shapes and sizes. And I think the best way to start is the basics.
Okay, but I think that is interesting, the point that you mentioned, like being intriguing and so on, because I think that this is very well connected to the whole mission of the company. So we have like such an ambitious target when it comes to using recycled material in our cells, reducing our CO2 footprint. And when you mention recycling, thinking about, for example, recycling, you mentioned prismatic or other sort of cells. I think that is also important to highlight that our recycling process is not only designed for recycling our own products or cells that are produced by Northvolt, but also products from other companies in the market, and not only cells. So if you think about how the recycling process starts, it will start with an operation that is called discharge. And all these operations that I'm gonna maybe explain a little bit about each one of them, not in exactly the same level of detail, they are represented in our R&D team. So we industrialize these operations, but we also have R&D focus on each one of them. So although I'm working mainly in one of the operations, we have engineers and experts developing and optimizing each one of them. So as I mentioned, the process starts with discharge. So we need to make these cells, or it could be modules or packs. So if you think about the whole battery that we have in a vehicle, we have a battery pack. Inside we have several modules, and the modules, they comprise plenty of different cells. So if we start with a pack, for example, or either a module or a cell, to be able to start the recycling process, we need to make this product safe for recycling. So we need to discharge it in the way that we are able to take out any remaining energy that is contained in it, to make it safer. And one thing that is very interesting when it comes, for example, to battery packs is that then we can imagine that somehow, considering the energy that's still contained in it, it's dangerous somehow, but it's impossible for us to discharge it before opening the pack. So we have
I actually had a question.
Yeah.
So when it comes to the battery packs, the majority, I mean, I would say 99% of them come to you at the R&D center or even an industrial level, still filled with a certain amount of energy, right?
Yeah, I would say so.
Yeah.
Yes. And then during the discharge process, we in the R&D center, we try to find ways to optimize this process and to make it better, and also to take back the energy that is contained in this pack and reuse it or bring it back to the grid, for example. So that's part of the R&D work. So after discharging these packs or modules or cells, so then you can consider that they are safer to continue to the next recycling operations. Of course, there will be dismantling activities after the discharge process. So we have this battery pack, and we need to make it smaller in the way that we can recycling it. So in the dismantling process, then we utilize manual operations, but also we have a lot of focus on automating this process. And then, as I mentioned, we have the pack and we have modules and cells. So the idea in the dismantling, we'll try to make it these different pieces a smaller one. So we are dismantling the pack into modules, and it could be also cells depending on the case. And there will be also other components present in the pack that will be dismantled or disassembled at this point. So after the dismantling process, then we can imagine that we have smaller portions of the whole,
like little Lego
pack.
blocks.
Exactly. I think that is a good association, like Lego blocks. So then these smaller fractions, so modules or cells, they will continue to a next operation in the process that is called usually crushing and sorting. We also call it mechanical recycling. So in this operation, everything starts with shredding the cells or the
Which is not
modules.
a light task because it's hard metal.
yeah, exactly. So if you think about the casing, that's correct.
Yeah.
It's not very soft.
No. So you need a pretty powerful machine to shred that.
Yes. So then we will shred the cells or the modules. And then in the mechanical recycling, I think that we can think that everything is associated to taking advantage of physical properties of the material. So if we have, for example, fractions that are lighter than others, materials that are lighter than others, then you can easily take advantage of these properties to separate different materials or different components in the modules or in the cells. So the idea is separating them, and then, for example, we separate copper foil, aluminum foil, polymers that are present in the separator. The idea at the end is to concentrate the metals that are contained in the cathode active material fraction in one fine fraction that is usually called black mass. So this fine fraction, we could think that is the final product of the crushing and sorting operation, and that's the one that contains mainly the cathode active material, so the lithium, manganese, the nickel, the cobalt in oxide form, and also the anodic material, so the graphite. And during the crushing and sorting operation, the idea is that we try to separate all the other components as much as we can. We liberate them as much as we can in the way that, for example, when we are separating the copper foil, we want to remove as much as the copper foil as possible, but minimizing the presence of the cathode active material or the anode fraction in the graphite. But we also don't want to promote a fragmentation of the copper foil and the other materials that much that it will end up in this fine fraction that we call black mass. So it's a kind of balance between fragmentation but achieving also the right liberation of the material.
Yeah.
And then from this fine powder, this fraction that is called black mass, that it's becoming more and more famous as the recycling is growing globally.
Is it a term across the industry for recycling batteries, black mass?
Yeah, I would say that is a term.
Okay.
Yes, that's true. It's a term. I don't think that there is a standard very well defined about what is black mass, but is a term that is well known. So this product from the crushing and sorting operation then is the feedstock for the hydrometallurgical circuit. And then in the hydromet process, that is also how it's called, the idea is then to try to, we could think, take this fine powder and then we are going to first dissolve it in an acid solution, and then all the metals that are present in this powder, they will get dissolved in the acid solution, and then the idea is using different technologies to separate all the different metals in the way that we will get at the end a product that can be reintegrated in the cathode active material production.
Yeah, because I think a misconception overall for people like me before I started working at Northvolt is once a battery is dead or has very little energy left, that there is valuable material left in those batteries. And I think that that's the interesting thing about the recycling process is that you figure out that there's a lot of valuable material still left. It's not destroyed it's still sitting there. It's still there. So I thought that was the most interesting part of learning about recycling.
Very, very interesting, this point. And also like thinking that we can even think about the batteries. So we can obtain the same metals coming from mining sources, from natural resources.
Yeah.
But we could also think about the end-of-life batteries as secondary resources that are highly concentrated in the same metals. So to be able to reclaim the same volumes of cobalt, for example, if you are thinking about ores, you would need a much larger volume than what you could obtain by recycling lithium-ion batteries.
Okay, really?
So it's very interesting from the sustainability perspective, and I think that also when we think about securing the source of these metals that are so critical for the production of lithium-ion batteries, as they are not easily available in the whole world.
Could you give us a basic analogy of what you just described as the process, the recycling process, so that people can understand?
So yes, I think that if we think mainly about the dismantling process and the crushing and sorting, maybe we can think about different Lego bricks that are part of like one.
Like someone who has just built something but needs to then take it apart to build something else.
Yeah, exactly. Yeah. That's correct. So you have built something with Lego and we want to dismantle in the original pieces of all of those Lego bricks. I think that we can think about the dismantling process and the crushing and sorting in this way. And in the hydromet process, I think that we could compare, for example, to having a piece of jewelry, for example, having different precious metals, and you want to separate each one of these individual valuable components that are present in this this necklace that you have, for example.
So it could be reused to make another beautiful necklace or other jewelry. It doesn't have to be a necklace. That's a great analogy. Thank you for explaining that. So when you're finished with this material, then how is this fed back into the process?
Okay, I think that is interesting because that's also one, I would say, strategical connection point between Northvolt and the recycling program, because all this development, all the recycling process, and this understanding about the products that we are producing in the recycling process was developed in close collaboration with engineers and experts that are working with the cathode development at Northvolt itself. So we need to assure that the products that we obtain through recycling, they can be returned with the same quality, the same level of purity to cathode active material production. And that was something that we have already proven in 2021. So that was when we produced the first cathode active material that was fully produced with nickel, cobalt, and manganese, produced through recycling. And then we also produced cells with this cathode active material. And we also demonstrated that the electrochemical performance was the same as cells that are produced with virgin material.
Yeah. Wow.
Not sure if I answered your question.
No, you did. You did. I think you did. So how much of the materials can Northvolt recover when they're going through this recycling process?
The recycling efficiency of this process is very, very high. And I would say that that's one of the main advantages of using a hydrometallurgical process, is that this is recognized as having high efficiency. We can recover the metals with a very high yield, I could say. And also the purity that can be obtained is also very high. Yeah. So when we think about hydrometallurgy in opposition to the main alternative technology in the market, that is pyrometallurgy, we can think that in the pyrometallurgical process, we are like burning, for example, a whole cell. So we can imagine that if we are burning something in using very high temperatures, then it means that first, the energy demand of this process is going to be very, very high. All the organic or carbon-based components that are present in the cells, they will be combusted. So, for example, graphite can't be any longer recycled because it will be combusted in the pyrometallurgical process. And then usually lithium also will form a very complex form that is difficult to be recycled, and all the other metals, some of them will not be possible to be recycled as well, for example manganese, aluminium, and the others, they will form a kind of a phase that will require further purification. So I would say that it's like somehow it's a simpler approach because you are just like somehow burning everything at once, but it requires also different steps for purification and separation. We have more losses usually, and purity may be also more challenging to be obtained.
So some of the materials change form then, that you then have to go and, like you said, do a different process to be able to bring them back to a different form, is what I'm guessing.
Exactly. Lithium, for example, in a pyrometallurgical process is usually ending up in the dust of this process. And then although there are technologies that claim that high efficiencies of recovery of lithium can be obtained, I think that is very, very challenging, or it will end up in the slag of the process that is a very challenging material to be recycled.
Okay, wow. Okay.
While in the hydrometallurgical circuit, you can obtain higher yields and also higher purity in the products.
That's a huge difference. Also just the difference between burning something, you're putting it into a liquid, right?
In the hydromet
hydromet,
process.
exactly.
Yeah, in the hydromet process, yes.
Does it get into high temperatures then?
No, we don't use high temperatures.
Right,
in
that's
the
what I thought.
hydromet.
Yeah,
Exactly.
So then,
that's one of the main advantages. And then, as I said, having the potential of recycling graphite, I think that is also something very, very important, considering that graphite in the black mass is such a high percentage of the whole fraction.
So then what liquid are you using? What did you say? You said
we use
like acid
solution.
Right.
So it's a solution containing water and one acid.
Okay, yeah. So huge difference between using something that burns it and a liquid that's just trying to gather everything it can from the material that you're feeding it.
Yeah, exactly. And I think that if we think, okay, producing these chemicals, it also has an impact. There is also energy requirement in the hydrometallurgical process. So there will be also some environmental footprint with this process. Yeah. But if we compare this with the footprint that will be associated to obtaining the same metals through mining, then there is a big difference.
Yeah.
And of course, then we have also the whole sustainability team that is usually also working in close collaboration with those that are developing and looking into new technologies for the future in the way that it makes sense also from the sustainability point of view, the choices that we are making in terms of technology. Yeah. And we are constantly looking into technologies, what we think that will come in the future, how the market will change, how the technologies will change. So we are constantly looking into it. Yes.
So I was just going to say that it's also fascinating that the big plant that is now up in Skellefteå on site is being powered by 100% renewable energy. So that in itself also, like you said, sustainable part of helping with the process.
I think that's very important to mention. And I think that also to think like from the development point of view that all the technological development started in our R&D hub and how the pilot plant that we have in the R&D hub was a proof of concept for this full-scale plant that now is getting into life.
I think I need to give the listener a bit of a perspective on how small this pilot plant is in labs compared to the large building or factory that we have up in the north. It was fascinating when I came there for the first time and seeing the final recycled material and just seeing the process, but on a very small scale. That's also R&D, so that's usually how it is. And it was just so cool seeing the whole process in this one space, which I think can't really do up at Revolt because of that, because it's so large. It's hard to get the perspective. So I appreciate that a lot at labs where you get the perspective of like the flow of how all of this works.
Yeah, I think that is when you go to the full scale plant is really massive, and then the pilot plant where you are working every day, although it felt maybe like. In my case, for example, I'm coming from academia, and then I was mainly used to work with smaller reactors, lab scale setup, and so on. And then you start working in a pilot, it feels that it's very, very big. And then you go to Revolt and then it feels, okay, that's a very small pilot plant.
Giant.
One that we have. Exactly. But it's also super interesting in the way that we can easily understand all the operations. So if you go to our pilot plant for a visit, you can easily understand how all the operations work. You can see what is happening in the reactors. So it's much easier to understand. And then when you go to Revolt, basically the operations they are the same, and maybe then you can't see what is ongoing inside the reactors, but you can fully understand based on what you see from the pilot.
I mean, it helps me in my job to be able to visually show it when going to Revolt labs instead of going to a major plant up at Skellefteå.
But it's also awesome impressive to see exactly this transition from a lab scale to a pilot scale, and then how we can upscale this into a full scale process.
Since we are recycling batteries, how much of the battery will eventually have recycled material?
Okay, so when it comes to that, I think that Northvolt has a very ambitious target that is having 50% recycled material in the cells by 2030. And that's very well linked to our ambition also when it comes to reducing our CO2 footprint, that is decreasing in 10 kilograms of CO2 per kilowatt hour, which is much lower than the reference in the market these days, that is 100 kilograms. And we can think that this is also very connected to recycling the materials that are used in the cells and not supplying them from mining, for example. It allows us to decrease a lot the CO2 footprint associated to it.
So all of that going hand in hand, and also together with vertical integration, just lowering that footprint as low as possible.
And I think that changing somehow like the way that we think about this industry and bringing more sustainability.
Yeah, exactly.
Because there's having a circular value chain.
A lot of materials out there, a lot of batteries that need to be recycled and fed back into the loop. So recycling isn't all rainbows and butterflies. There are always obstacles and challenges. What kind of challenges is there in the recycling field right now with batteries?
I wouldn't think only about having the volumes available for recycling, because as we talk, this is an industry that is growing in the whole world in the same way as the battery industry is growing in the whole world. So I wouldn't say that only having the volumes available to be recycled, because having end-of-life batteries available to be recycled, I wouldn't say that that's the main one, but probably thinking about how the technology is evolving so quickly. And all the challenges that this represents to recycling, because if you have different chemistries coming to the market all the time, if you have different materials that are being considered or using different dopants, so many different things being considered and also coming into the market, that requires being aware, knowing about this and understanding how this can potentially affect the technology that you are using and how you need to improve it for the future. And I think that then this is also interesting, being vertically integrated with Northvolt and having an R&D team that is collaborating so closely with so many other teams at Northvolt. So as I mentioned, the cathode active material development team, we can have an understanding about what we anticipate that will come in the market in the future, what are they considering, and also giving this sort of feedback that, maybe that's not the best alternative, or we should try something different. So not only from the hydrometallurgical perspective, but when we talk about dismantling, for example, in the way that, for example, different materials are used when assembling the modules in a pack, for example, glues, foam. So also having this understanding about the design for recycling and advising, for example, other OEMs about this, how that could be made in a way that will be more easy to be recycled in the future. So I would say that keeping up the pace with all these changes and also the variability, because if we are producing something, we are usually producing the same, and then you have, for example, more easily automation in this process because you are always producing the same. When we think about dismantling, that's one of the big challenges that we could highlight. As I said, we are not aiming to recycle only our own cells, so being able to recycle packs that are coming from the market and then being able to work with such a huge variability, because not every pack will be the same, is more the opposite. You have so many different options in the market. So it's, I would say, the variability and how the technologies are changing and new things are coming.
Yeah, because you have to then make sure that whatever automated system that you have can then be used when something new comes in.
Yeah, exactly.
Yeah, you can't just be sidelined and all of a sudden realize, oh wow, we can't do this because we have it automated for this, and that, or just or certain battery packs.
Yeah, exactly. Yeah. It's just for like Lego bricks that are assembled in a certain way.
It needs to be different sizes and shapes, and because I actually just visited Revolt Hamburg. And it was very interesting to see is that there are huge challenges with OEMs that have certain ways of how they put these packs together. So glue, what was the other thing you mentioned? Foams, exactly. And actually I talked to one of the colleagues there. I'm not going to name names of people or which OEM this was, but they were talking about the challenge with certain suppliers then of these packs that have either way too much foam or glue, and it becomes very difficult to take them apart. Very, I guess, energy and time consuming to figure out how to remove those. So I think it's a very good dialogue to have. Okay, so how do we make these battery packs easier for us, Northvolt, to recycle or other recycling partners? And I think that it's super important, because if it makes it more difficult, then that also could minimize those battery packs being recycled.
And I think that this is also one positive point of having an R&D hub, because then we can create all this understanding. We can create this collaborative way of working, that we can feedback about what are the problems and the challenges while recycling these products. So all of this understanding is something that we can develop in our R&D team. As I said, we have experts working on all these different operations and trying to optimize them.
Exactly. And you're all in the same location. That's what I love about labs, is that it's very small. That's for a reason. But that everything that is on a massive scale up in Skellefteå is literally in a small scale in labs. So you can cross collaborate. And it's just so great to see that those things that you are working on are then literally brought up and replicated up at a massive factory. It's pretty awesome. Okay, I'm going to end with a pretty philosophical and I guess quite difficult question, because you've already kind of got into it. But what does the future of battery recycling look like to you? What do you think it will look like in 10 years' time?
I think that we will see much more the use of automation, taking advantage of inline analysis methods, machine learning, artificial intelligence, but also a lot of focus of minimizing even further the use of energy, the use of chemicals, like trying to find more innovative ways that we can maybe like regenerate the chemicals that we are using in different ways. So I would think about really like a transformation in the way that we see recycle.
Do you see other battery manufacturers also dipping their toes in the recycling business as well? Or do you think that that's still going to be where it is now?
I think that a setup as the one that Northvolt has is not the most common existing, like this vertical integration. So I would say that there are some players that are active also on the cathode active material production, also into the recycling sector, but having like this kind of way of covering the whole value chain and really having this vertical integration, I wouldn't say that is something pretty common.
Yeah. Okay, thank you so much, Nathalia, for coming in and talking about recycling with me. And I hope that anyone listening enjoyed hearing about Northvolt's process, but just the general process of hydromet process of recycling batteries.
Thank you so much. Thank you for inviting me again. It was very nice.
Thank you for coming, and thank you guys for listening.